Hello students, in this video I'm going to show you how to graph an exponential function. As we said during class time, exponential function is the form y equals b to the x power. I'm going to get an example for you. Y equals 3 to the x power. Remember here we are saying the exponent is a variable and we have been used to like y equal x to the third power, like cube equation. But in this case we have an exponential and the variable is here. Now how can we graph an exponential function? An exponential function can be graphed as other function by using a table of graphs. So to use a table, you can take some values for x and y. For example, x and y. If x is -3, -2, I'm taking some values on the negative side, and I'm going to take some values on the positive side on the number line. If x is -3, the only thing is you have to substitute -3 instead of x. So you're going to say 3 to the power of -3. When you deal with exponential function, you have to inverse the exponents. You have 1 over 3 to the third power, which one is 1 over 27. The second point is -2, so we have 3 to the -2 power, the same procedure, 1 over 3 squared, which one is 1 over 9. -1, 3 to the -1 power, 1 over 3. Now in the moment that we have 0, 3 to the 0 power is 1. And now with the ones, 3 to the first power is 3, 3 to the second power is 3 times 3 equals 9, and 3 to the third powers equals 27. Now it's just simple our job to plug this on the number line and take a look on the equation. So I'm going to just create a number line up here and start to label the graph, x and y's, and put some values here for -1, -2, -3, and some values on the right side of the graph. This is the origin, 1, 2, and 3. Okay, so relating the y's, I'm going to pick some values here. The graph goes through 27, which one is a big number. So, and starts with 1 over 27, which one is a very small decimal number. So I'm going to continue through 9. So I'm going to pick 1, 2, 3, 4, 5, 6, 7, 8, and 9. And you can continue after with the graph. Now, as you can see, if you plug -3, the function is here very, very small. I'm going to use different colors. We can see better the graph. For -2, we have 1 over 9. For -1, we have 1 over 3. For 0, we have 1. For 1, we have 2. So you remember, you connect these points. This is like a simple sketch just to create us an idea. And for 2, we have 9. Okay, so we go up, connect with the 9. Okay, so if I connect the points here, that's my graph. Now, yeah, so you can tell now that the graph is approaching here to the x-axis. It's never ever going to touch the x-axis, and it's increasing very, very, very fast. And that kind of increase is called exponential growth. It's not like linear. You remember, if you compare the linear functions, a linear function is like that. Grows, but grows very slowly, comparing with the jump that an exponential function does, that grows very, very, very fast. And to analyze this graph, as we did in classroom, you have to analyze based on domain, range, and behavior. You can talk about if the graph is continuous or no, and try to include the new word that we just learned, the asymptote. I'm reviewing one more time the word asymptote. Asymptote is the line that my graph approaches but never ever crosses. In our case, the x-axis is the asymptote. Take a look. My orange color, my real graph, approaches on that. Approaches, I can tell, approaches, never ever cross it. So asymptote is x-axis in this graph. If you want to talk about domain and range, as we said, domain, in this case, for domain you take one value and you really touch the graph. Any value here, you really touch the graph. Remember, the graph never ever ends, goes to positive infinity. So what can we say for the domain? Domain in this case are all real numbers. So let me erase a little bit, open a little space for myself. So I can say domain are all the x's such that x is part of real numbers. For the range, as you can tell from the graph, on the negative side of the y-axis we don't have any graph. Our graph starts from 0 and up. So we can say y such that all the y's are greater than 0. Now, a good discussion in this point is, can we include the 0 or no? To think about that, you have to think the definition of the asymptote. We said the asymptote is a line that our graph approaches but never ever cross it. So by this means that we are not going to include the value y equals 0 because the graph never ever is going to cross the x-axis. So again, x-axis is an asymptote and the y is greater than 0. So that is the domain and range for that graph. The graph is continuous. We don't have any discontinuity point here, and the graph goes up and is increasing. So this kind of graph that increases has a name. This graph is called exponential growth. I'm going to write here exponential growth. Exponential growth. Why is that growth? You can tell the graph is growing. And the most important thing, we have to look at the b. In this case, b is equal to 3. So b is a number greater than 1. So when we have exponential growth, when b is greater than 1. And that is very, very important. So in this lesson, we learn how to graph an exponential function, how to analyze the graph of exponential function, and we learn how to find the domain and the range. Thank you.